Hi guys, good morning. So in the last session we started with the switching part, okay, and today we'll be going with our first topic, which is about L2 forwarding. Okay, so this is your Encore book, and in this Encore book, you can see like first chapter is about forwarding, and it is about packet forwarding. Okay, so in the packet forwarding, if we take a look, right? So let me just go to the curriculum. See here. So the first chapter is about packet forwarding, and this includes both the types of forwarding. It includes your L2 forwarding as well as your L3 forwarding. Okay. So today we'll be discussing about the L2 forwarding part because switch is what? A L2 device. Okay. L3 is all about your routers. Okay. So now let's start from the L2 forwarding. They were just waiting for us. Okay. No, this is on the ground, first floor actually. It feels like coming from the third floor. Okay. So the first thing is about network device communication. Okay. So your networking journey also you started with the network only. And what's the network? Connection. Devices interconnected to each other. Okay. Why? Mhm. For communication to share the resources. Okay. When you say resources, what do you mean? Can be file or something. That means an information only, right? That means information. Then what is data? There are two things, right? One is data. Then we have information. So what is data?
Collection of informations.
Collection of information. And what is information? Hmm? You say sharing resources, files, information, data. But what is the difference? Hmm? Data breach. What is data breach? Unauthorized access to data. But what is data? Hmm? Anything that has to be stored. We store groceries also, right? That is also data. No. Then it can store the form of bits and bytes. Okay. But what is data? Hmm? You consumed your 90% data. Every day you get that kind of messages, right? What is data? Amount of information. Okay, what is information? Basically, anything can be a data. Okay, data is the raw form. Okay, if everything is a data, let's say anything about you, all your information is what? Data only. But there is a slight difference. Data is the raw form. Let's say something traveling in the cables. That is what? Signals, data. But that doesn't have a meaning. What is information? Information is meaningful data, valuable data. The data that has some information. So actually, what we are trying to protect, whenever you talk about security, right? What you're trying to protect is information. When you encrypt something, that is what? Encrypted data. Nobody understands that without decryption. After decryption, it becomes clear text. Clear text means now it has some value, it has some meaning. That is information. Understood? Now you are saying that okay, we have the networks. We have the networks. And you say network is what? Interconnection? Yes or no? You tell me that okay, this is the interconnection of two or more nodes. Correct? And the reason you tell me is you say that okay, we want to exchange what? Information or data with the help of networks. So without network, can I not do that? Can I not exchange information? When you are not having networks, are we not writing the letters? You are still exchanging the information. Yes. You are still exchanging files. Digital files also can be exchanged. You are using storage medias like floppy disk, CD drives, pen drives, you can say. So information was being exchanged without network also. Then what is the need of network?
It reduces time and saves cost, and
Good.
we can share data more secure.
So many things are there. Security is there. Reliability is there.
Yes, security, like
Integrity is there. Portability. And when you say remotely, you can share the data. That means what? We are able to copy from one device to another device. Yeah, so we can also do that without networks. Storage medias. But these were the major concerns. Okay, and with the help of networks, we are also able to maintain what? We are able to maintain confidentiality because we have encryption protocols and all, right? So what is confidentiality? Privacy. What is privacy? Not asking synonyms. What is confidentiality? Right person, right access, wrong person, wrong access. Correct? But you can say basically that only authorized people have access to the information. That is what confidentiality is. So, as the word itself says confidential, that means something that is not to be disclosed to everyone, not to be shared with everyone. Only selected people, authorized people should have the access to it. That is confidentiality. What is integrity?
There is no alter in the data.
Right. The information
Data is not altered.
Exactly. The information is altered. That means there is unauthorized changes in the information when the information is at rest and is it in transit. Both the times when it is traveling in the network or it is at rest, both the times there is no change of or alteration of information. There is no unauthorized changes. That is integrity. Clear? So we are able to maintain all these things with the help of network. But if we talk about real time, are we actually secure? No. Why? What about your information? Is it confidential? Why? Why not confidential?
so the hackers can hack the information anytime, anywhere. So we can't secure data 100%.
How many think you are hacked?
No. But we are trying to secure.
No, my question is how many of you think you are hacked right now?
Yeah,
Okay,
we are
through the internet connection or network, if
okay. Whomsoever is
any
using
hackers connect
all
my
the
network or know my no.
One by one, please. Yes,
okay.
please.
Yeah, so anybody is using an Android device or an iPhone device or any smartphone, your data is already compromised. So uh, big players like Google and Apple, they have all the data of ours. So everything is tracked. Your contacts, your photos, your travel, everything is tracked. So the data is already been compromised.
So that means as much as we don't know about us, those
Right.
big knows.
So the big giants, they know what we did a couple of years back.
They are using algorithms to predict what you want. What is the next thing you would like? Right? Yes or no? Right now, you talk about phone calls and you start seeing ad of the same things. Imagine that. Hmm? How many of you are using Android devices specifically? Everybody. So many are using Apple also, right? So everybody is using Instagram, Facebook. Have you seen the permission they are using? They are having from your device. What kind of permissions? Storage, mic, camera, contacts.
Contacts.
That is something, just an overview, you know. That is just an overview. Have you gone into the details? No. Model number. I'll show you something. Let's say everybody uses it, right? Just very small number of permissions, right? Go through it. Read the calendar, please. Interesting, right? Yes or no?
Yeah.
Okay. Then everything, all your phone numbers, call logs, they are able to directly call phone numbers also, right? They are able to completely modify or delete the contents. Then see here some of the interesting permissions. So the level at which we are being tracked is at a very high level. That means they leave nothing behind. You install the application and everything is good. Okay. They are able to control your Wi-Fi connections. They have your full network access. They can change your network connectivity, right? There's nothing is left. Everything is there. Okay. Now, how this is possible? Because of networks. This is also because of networks. Otherwise, if you don't have a network, they're not going to bring a pen drive to you and will say that, okay, give me your data. Right? This is also because of networks. So everything has a good and bad. Everything has its own good and bad. A good side and a bad side. Advantage and a disadvantage. So definitely for the communication, we have to take care of it. Okay, we have to decide what kind of applications we should use, what kind of applications we should not use. Before installing an application, we should see that, okay, what kind of permissions it is taking. Right? Sometimes what will happen, people will say that, okay, this is the application, and download it directly from Google and install it and start running it. Right? So you have to avoid that. Now coming to security, so our security, who is going to be responsible for it? We ourselves, right? So you have to use VPN connections. Right now, most of you are aware, but there was a time that everybody liked free Wi-Fi, right? At railway stations, every day you would see a lot of people sitting around just to use the free internet or free Wi-Fi. Okay, and there's a lot that can be done. So network is interconnection, and today is the scenario where everything is connected. Where everything is connected. Okay. So without network, we were able to exchange the information, but it was time taking. There were some issues like, high cost, high time, less security, less reliability, integrity issues, confidentiality issues. To avoid all those issues, what were designed? Networks. So with the networks, what happened? That we started having faster communication. We started having faster communication. And everybody knows that the entire world is connected with the what kind of media? Cables. What kind of cables? Right? Fiber optic
Fiber
cable.
opticals.
So the entire world is connected with the fiber optic cables. And in the fiber optic cables, what kind of signals is traveling? Light signals. Now this is very fast, right? Why? Compared to copper, this is very fast. Why? Speed of light. What is the speed of light? 3 into 10 raised to power 8 meter per second, which is around 3 lakh kilometers per second. Okay. This is the speed of light. In 1 second, 3 lakh kilometers. And what is the circumference of Earth? What is the circumference of Earth? Everybody knows circumference, right? What is circumference? Diameter. No. Boundary. Circumference is the boundary. So what is the length? It is approximately 40,000 kilometers. Now you can imagine in 1 second how many times the signal can go around the Earth. Approximately 7 to 8 times. Okay. Within 1 second, a light signal can travel around the Earth 7 to 8 times. That is the reason that we are having so fast video calls. Lag-free video calls. Real-time video calls we are having. There was a time that, okay, we used to speak and the signal used to come back. After some time, we had to wait. But now, that kind of thing is not there. Why? Because the signals are fast. Okay. All right. This is clear about network. Okay. So the primary function of a network is to provide what? It's to provide connectivity between the devices. Okay. So there used to be a variety of network protocols that was specific or preferred. There was time when there were proprietary protocols, right? There used to be proprietary protocols. All the manufacturers, they used to have their own protocols for their devices. There was a time when multi-vendor communication was not possible. Why? Because everybody was using their own protocols, right? Kind of, you can say they were not having a common language for communication. Okay. So when you don't have a common language for communication, is it possible for you to communicate? Let's say, for example, if we take an example, let's say this is person number one, this is person number two. This guy is from India. And this guy here, he's from, let's say, Japan. Now, person from India, he will speak the mother tongue, which is Hindi. And this guy will speak what? Japanese. Now imagine they are communicating with each other. This guy is speaking in Hindi and this guy is speaking in Japanese. Will there be any communication? No. So same thing was happening. If this is Dell and this is IBM, they were having their own protocols for communication. The protocols decided how their devices will respond, right? How their devices will communicate. So they were not communicating. Dell was not communicating with IBM. IBM was not communicating with Dell. Problem was there. Not for the companies, because company knew that, okay, if somebody will purchase even a mouse from me, then that mouse will not work with any other devices. So that means if you want to design a network, the entire network has to be designed specific to the vendor, right? So companies were in profit. But as the time came up, everybody saw the problem. Everybody saw the problem. And the organizations like ISO, they came up with the solution. What they came up with? Standard protocols. They came up with standard protocols. That means common protocols for communication. It was similar to, like, we have English. Now they have a common language for communication. So they can easily exchange the information. Same thing was here. They were also having common protocols for communication, and the communication started, the interaction between the multi-vendor devices started. This is clear? Okay. So almost everything is based on what? TCP/IP. So it is important to note that TCP/IP is based on the conceptual OSI model. That is why your OSI model is also known as the reference model, because even your TCP/IP is referring to the OSI. Okay. That is composed of how many layers? 7 layers. Okay. Each layer describes a specific function, and a layer can be modified or changed without requiring changes to the layer above or below it. That means if there is any change at a specific layer, that will not affect other layers. How the other layers are functioning. They are independent of each other. They have their own functions. This is clear? Okay. Now 7 layers are there. What is the layer 5?
Layer.
Or presentation. What is the layer 3? Data link or transport?
Okay.
Layer 3 is network layer. Okay. So these are the 7 layers. So we have application, presentation, session, transport, network, data link, and physical. Now OSI model you have studied very well in your CCNA, right? So a brief is given here that your application layer is responsible for interface, for sending and receiving the data. That means providing a UI to the user so that user can put in the information and receive the output. Okay. Presentation is responsible for formatting of data and the encryption. Session layer will track the packets by generating and creating and maintaining the sessions. Then transport layer is responsible for end-to end communication. Network layer is there, which is responsible for your logical addressing. Logical addressing means IP addressing, right? Also responsible for routing of packets. Now, what is routing? Determining the best path to reach the destination. Okay, the process of finding the best physical path for data transmission is routing. Then we have data link layer, which is responsible for hardware addressing. Hardware addressing means MAC address. Okay, and I believe now you know MAC address can be changed or cannot be changed, right? Then physical layer is there, which is responsible for media type and connector, like what kind of transmission media will be used. Copper media, fiber media, radio waves, right? So that all will be the part of your physical layer. Okay. So see here, when you think of about the flow of data, most of the network traffic involve communication of data between the application. Because how, let's say for example, I am sending a text message. Now we have a WhatsApp group, right? What is it? An application. So whatever information I have to provide to you, whatever the information I have to exchange with you, I will be providing through the application, and you will be receiving in the application only, right? It's not like you will pick it up from presentation or transport layer. Output will be there in the application only, right? So same thing here. Majority of the communication, most network traffic involve communication of data between the applications. So the application generate data at which layer? Layer 7. And the device or the host who is going to send the data will send it down the OSI model. We know that on the sender side, okay, on the sender side, that data always travel from layer 7 to layer 1. Because the sender will provide the information in the application, then it will go through the encapsulation process through the different layers, and then at the physical layer, it will be transmitted to the cables or whatever the media being used, right? While on the receiver end, what will happen? The reverse process will take place. The data will travel from layer 1 to layer 7. Because the receiver will receive it at layer 1, then decapsulation process will start, and finally the user will get the output also in the application. Yeah. As the data moves down the OSI model, it is encapsulated or modified as needed. This is clear. Okay. Then at layer 3, the device or the host decides whether the data needs to be sent to another application on the same device, and it would then start to move the data up the stack. That means if in the same device only you are exchanging the information from one application to another application. So it will come at the network layer, it will see, okay, it is for me only, and it will remain within the device. But if it is traveling to a different device, or if the data needs to be sent to a different device, the device host will continue the processing down the OSI model towards the layer 1. So we know that, okay, if it is going to a different device, then only it has to go through the cable. If you are copying from one application to another application, let's say Paint to desktop, desktop to Paint, or I'm copying from one application to another application, maybe Notepad to Paint or something like that. So it doesn't have to go through any kind of cables. It has to remain within my system only. Okay. Layer 1 is responsible for transmitting the information onto the media like your cable, fiber, radio waves, right? On the receiving side, what will happen? The reverse process will take place. The data will start at layer 1 and then move to layer 2 and so on until it has moved completely up to the layer 7, right? Same thing we discussed that, okay, sender side data will travel from layer 7 to layer 1, and receiver side, the data will travel from layer 1 to layer 7. Yeah. So now here we will be focusing on what? Layer 2 forwarding. So this chapter reinforces concepts related to how a network device forwards traffic from either a layer 2 or a layer 3 perspective. So right now we will focus on layer 2. So first, a layer 2 network device were what? Bridge. What is a bridge? What is a bridge? Hmm? What is a bridge?
Is that hub or switch or meaning to travel data between two devices that we need device, right? So the device will be the bridge.
Sorry, come again.
Like hub or switch, some devices, right? So we are connecting the devices, the end nodes to devices. That devices are used called as a bridge, right?
That is I used to connect hubs. Hubs. So what is a bridge? Hmm? See, initially we were having the hubs. How many collision domains were there? Per port in hub. Hub has a single collision domain, only one collision domain, right? So if you have two departments, now two departments are there which want to communicate. Maybe they want to exchange information. But again, there is what? A single collision domain. That means at a time only one device can send the information. Right? Problem is there. Collision will be there and all the hubs will be down. Correct? So bridge is what? Bridge was a technology that was introduced to divide the collision domain. To divide the collision domain. That means if you have two hubs and you want to divide the collision domain between them, then you used to use bridges. Okay. Then slowly, once the collision domain was divided, like this bridge was having like two interface only, where you can connect two hubs, so that the collision domain between the hubs can be divided. Okay. And later on, some improvements were made and per port collision domain came up with the switches. Per port collision domain came up with the switches. Clear? So bridge, you can say this was a transition between hub and switch. You can say this was a transition between hub and switch. That means
It's a layer 1 device, no?
yes. Okay. Understood? Okay. Now, so the first layer 2 network devices were bridge. Okay. So your bridges or switches, they are what? They are layer 2 devices. Okay. And layer 3 devices were strictly what? Routers. Layer 3 devices were strictly routers. As technology advanced, the development of faster physical media required the ability to forward packets in the hardware through the ASIC. This was a major improvement made in the bridges. Bridges used to use hardware. They used to use hardware for the forwarding. Okay. But that was kind of slow. That was kind of slow. So application specific ICs, application specific ICs or application specific integrated circuits. That means kind of chips, you can say. Those were made to make the process faster. Okay. So in the switches, what was introduced? ASIC. Application specific ICs. That means a chip that performs a specific task. Okay. Now it's not a hardware that will deal with all the traffic. There are specific chips that are doing specific tasks. Okay. So these ASICs were introduced and the switches became fast. Clear? As the functionality continued to develop, multi-layer switches were also invented to power the layer 2 traffic in the hardware as if they were switches. Now, multi-layer switches, by default, they also work as a L2 only. But we can start L3 functionality also. They do have L3 features as well. Clear? However, they can also perform other functions like routing packets from a layer 3 perspective. Okay, so by default, they are working as a L2 only, but they can also work as a L3. This is clear. Now, if we talk about L2 forwarding, the second layer of OSI model, the data link layer, handles the addressing beneath the IP protocol stack, which is your physical addressing, right? So that the communication is directed between the host. We know that the switches, they,
Sir, for a routing, router we give the command no IP routing. No? For make such type of command is required to make it layer 3 switch for this type.
yes, we have to disable the L2 characteristics. Okay, so interface, on the interface, you can disable it by giving the no switch port command, and
Oh,
for the IP routing, you can give the IP routing command in the global configuration mode.
then only it will act as a L3 switch, right?
Exactly.
Okay, thank you.
Okay, so the network packets, they include L2 addressing with the unique source and destination address. Okay, L2 addressing with unique source and destination address. So we know that, okay, in the L2 header, source MAC, destination MAC information is attached, right? Ethernet commonly uses what kind of address? Your media access control address or MAC address. Okay, and other data link layer protocols like frame relay and all, these are other technologies which use completely different L2 method of addressing. Okay, but these frame relay networks, these are not really being used right now. They have been replaced by the MPLS technology. Okay, so right now we do not need to worry about the other addressing method. Right now we just need to focus on MAC address only. Clear? So the focus of the enterprise core exam on the Ethernet and wireless technology. You see, core exam is on the Ethernet and wireless technology, and both of them use what? MAC address only for L2 address. So like I said, even your core exam is based on MAC address only. So you don't need to worry about frame relay technologies and all. Okay. Now, about MAC address, we had already seen that, okay, this is a 48-bit address. In the last session, we had seen that this is a 48-bit address that is split across 6 octets. Okay. So again, that will depend from OS to OS. Okay. How it is denoted in 6 or 3, that will vary. In Cisco, it is divided into 3 only. Okay. And notated in hexadecimal. Okay. The first 3 octets are assigned to a device manufacturer known as organizationally unique identifier. We know that the MAC address is made up of 2 parts, OUI and the vendor specific, right? So first 24 bits, they are the OUI, and the manufacturer is responsible for ensuring the last 3 octets. That means the last 24 bits. Okay. So the device listens for network traffic that contains the MAC address as the packet's destination MAC address before moving the packet up the OSI stack to layer 3 for processing. Now, what does it mean? Let's say, for example, a postman comes to your home. He will give you a letter. Now, you will accept that letter only if that letter has the address of your home. Right? Same way, a NIC card will accept a particular packet or a frame, okay, only if it has the destination MAC as the device MAC. Only then they will accept it and forward it to the upper layers. Otherwise, they will drop it right there. Okay. And then we have network broadcast with MAC address all X. That is the universal broadcast MAC address, you can say. These are the exception to the rule and will always be processed by all the network devices because broadcast is what? One to all. So that means it is supposed to be there for everybody. So everybody will. Broadcasts are not typically. When you say layer 3 boundary, what it means? A broadcast traffic never travels from one interface to another interface of a router. Router never forwards a broadcast traffic from one interface to another interface. Clear? So that is also a limitation of broadcast domain. See, switches have a single collision domain, single broadcast domain. Then switches came up, divided the collision domain, per port collision domain. But still broadcast domain was single. So to divide the broadcast domain, routers were there. Yeah. Now about collision domain. So we had already discussed what is a collision domain, right? So collision domain, it's a network or part of network where there's a possibility of collision. Okay. So that means if there is a device like a single collision domain and there are two nodes which are trying to communicate simultaneously or at the same time, there is a possibility that there will be a collision. And if there will be a collision, then what will happen? Up will go down, no communication at all. So does it mean that, okay, two PCs are there, so when a first PC will communicate, when second PC will communicate, it has to be decided? No. How long you will decide? Because there are protocols consistently working, right? So they have a process that is known as what? CSMA CD. So there's a process, CSMA CD, carrier sense multiple access collision detection. So this technology or this process was used to detect the collision. Okay. So the Ethernet devices, they use this CSMA CD to ensure that only one device talk at a time in a collision domain. In a single collision domain at a time, only one device should communicate or forward the traffic. So how does it work? Any device that wants to forward the traffic will first try to check whether the media is free or not, or is somebody else transmitting some information. So if they find that somebody is transmitting the information, they will wait. If the media is free, then they will start transmitting the information. This is how they used to avoid the collisions. Okay, or what we call it as a smart hub. Okay, they used to check. Now, if a device detects that another device is transmitting the data, it will delay transmitting the packet until the cable is quiet, until the media is free. This means device can only transmit or receive data at one time. That is basically what happens. This is clear. Okay. As more devices are added to a cable, the less efficient network becomes, as the device will wait until there is not any communication. Because if more number of devices you add to the hub, the waiting time will be large because any device will try to communicate. And there's a possibility that two devices are checking at the same time. They find that media is free, and then both of them will start transmitting the information at the same time, and collision will happen. So that is how your networks will become what? Less efficient. The networks will be less efficient. So since all of the devices are in the same collision domain, it will become less efficient. Now, network hubs will proliferate the problem because they add port density while repeating traffic, thereby increasing the size of the collision domain. So even if you connect two hubs, still single collision domain, single broadcast domain. Still single collision domain and single broadcast domain. Why? Because hub is a non-intelligent device. Hub is a dumb device. Any traffic coming to a hub will broadcast it to all the ports. Okay. So network hubs do not have any intelligence in them to direct the network traffic. They will simply repeat the traffic out every single port. This is clear? Yes or no? Okay. And this is why we needed what? Network switches. Okay. So what switches did? They enhance the scalability and stability in a network through the creation of virtual channels. That means they had some virtual paths, dedicated path from one port to another port, which caused what? Per port collision domain or active port collision domain. Okay. So a switch maintains a table that associates with the host MAC address to the port that source network traffic. Now, that means what? Switches maintain a table that, okay, on which port what device is connected. That means a port to MAC or port to device mapping is there in the switch. Okay. So how switch creates this table? When it receives a frame through a port. Okay, so it will capture what? The source MAC address. Okay. So if we take an example here, right? Let's say we have a switch. And we have two PCs. This is a switch. Then here we have the PC1. And let's say this PC1 has the MAC address M1. Okay. This side we have PC2 as the MAC address M2. Then this is, let's say, for example, F0 by 1 interface of the switch. And this is F0 by 2 interface of the switch. Here we have the IP address, let's say 10.1.1.1. And here we have the IP address 10.1.1.2. Now these two nodes, they want to communicate with each other, right? So let's say you'll go on PC1 and you'll say ping 10.1.1.2, right? So these PCs, they also maintain something called as ARP cache. The PC maintains ARP cache. In the ARP cache, we have the information about IP to MAC mapping. So here, let's say this is the IP address. This side we have the MAC address. Same thing in the PC2 also. Then switch will also maintain one table, that is CAM table or MAC table. CAM table or MAC table. And in this table, port to MAC mapping will be there. Also, VLAN information will be there, but right now we haven't discussed. So Also, mathematics. This thing will be there, right? And initially everything will be empty only. Nobody will have any kind of information. Now, let's say, for example, PC1. So you went on the PC1 and you gave the command ping 10112. So PC1 will generate what? ICMP, right? PC1 will generate ICMP. So in the ICMP, PC1 will say, this is ICMP packet, ICMP echo request, right? In this ICMP echo request, there will be source IP information, there will be destination IP information, there will be source MAC address, there will be destination MAC address, right? So source IP address, PC1 knows its own IP address. So that will be 10.1.1.1, right? Destination IP address. Now you have given in the ping command that what is the destination IP address. You mentioned it in the command that okay, you want to reach where? 10.1.1.2. Then source MAC address. So PC1 knows its own MAC address also. That my MAC address is M1. But for destination MAC address, it will check the ARP cache. PC1 is going to check what? ARP cache. That okay, do I have any information in the ARP cache about the MAC address for 10.1.1.2? So do you see any information here? No. So that means this information is missing. This information is missing. So what PC1 will do? PC1 will hold this packet, will not drop it. Okay. PC1 will hold this packet and it will generate a new packet, which will be ARP request. In the ARP request, it will say source IP, destination IP, source MAC, and destination MAC. Source IP will be same. PC1 knows its own IP address. Destination IP, we know that whose MAC address we want to fetch. 10.1.1.2. Source MAC address, PC1 knows its own MAC address. Destination MAC address. This will be a broadcast. So, okay, all right. So let's keep it small. Let's say all right. Now this is the ARP request. Now this packet information is complete. So PC1 will forward this packet. PC1 will forward this packet through the interface and this will reach where? To the switch. As soon as switch receives this frame, the first thing switch will do is what? Switch will check that okay, on which interface it has been received. So switch will check here that okay, I have received a packet through which port? F0/1. Okay, then it will check who sent me this packet. Source MAC, it will check. I have received it from M1. That means if I have received information from M1 on this port, that means M1 I can reach where this port. Right? So switch has stored this information. Right? Okay. Then switch will check what? Destination. What is the destination? It's a broadcast. That means how switch is going to deal with the broadcast message? It will flood through all the ports except the port it was received on. Okay. Switch will forward the message through all the ports except the port it was received on. So as of now, we have only 2 ports. So the message will be forwarded to the interface 0/2, and through this interface, it will reach where? PC2. Once PC2 receives this message, PC2 will check first of all for whom this message is. It's a broadcast. That means I have to process this message. So it will process the message and then it will send it to the layer 3. Layer 3 will check that okay, this is what? 10.1.1.2. Is it for me? Yes, it is for me. Then somebody, the PC2 will see that what kind of message it is. ARP request. That means somebody is seeking my MAC address. then PC2 will respond. But before responding, what PC2 will do? Will make an entry that okay, I have received a packet from whom? 10111. And what is this guy's MAC address? M1. Done. Then PC1 will respond. Sorry, PC2 will respond with the app reply. It will say source IP address, my IP address is 10.1.1.2. Then destination IP address, this will be 10.1.1.1. This is the guy who is looking for my MAC address. Source MAC address. So my own MAC address is M2 and destination MAC address. So I am forwarding the packet to whom? 10.1.1.1. Do I have an entry in my app cache? Yes, I have an entry in my app cache. What is the MAC address for 10.1.1.1? M1. So this is M1. Done. Packet information is complete. Okay. So PC2 will forward it through the interface and this message will reach the switch. The switch is going to do what? We'll see that, okay, I have received some information on the interface F0 by 2. Okay. So what switch is going to do? I have received the information on the F0 by 2. And who sent me this information? M2. Okay, that means I can reach the M2 MAC address via F0 by 2 interface, right? Okay. Then it will check the destination. What is the destination MAC address? M1. So do I have an entry in my CAM table? Yes, for M1 I have an entry. How I can reach? Via F0 by 1. So I'll just forward the traffic to the F0 by 1 interface and it will reach the PC1. Now PC1 will see it and PC1 will make an entry in the app cache. PC1 will say that okay, I have received a reply from whom? 10.1.1.2. What is this MAC address? M2. Now this packet was on hold. So what PC1 will do? Will say, okay, now I know the information that this guy's MAC address is what? M2. Okay. So now here information is complete. So ICMP echo request can travel. So PC1 will forward this information through the interface and it will reach the switch. Switch will check that okay, who is the source MAC address? M1 on which interface? F0 by 1. Do I have this information in my CAM? Yes. What is the destination MAC? M2. So how to reach to M2? Check in the CAM table. I can see that okay, M2 I can reach via the interface F0 by 2. Okay. So via the interface F0 by 2, the message will be forwarded to the PC2. Then PC2 will respond with the ICMP echo reply. Okay, so it will say source IP, destination IP, source MAC, and destination. Source IP 10.1.1.2, destination 10.1.1.1 source MAC address, M2 destination MAC address, check in the app cache. That is M1. Okay. So all the information in the packet is complete. That means we can forward it. Okay, switch will see that okay, on the F0 by 2, I have received a packet from M2. Do I have the information in the CAM? Yes. What is the destination? M1, how I can reach? Via the F0 by 1. Forward it here and the reply will come. This is how the successful communication or the packet flow takes place. Understood? So this is how your switch populates the CAM table. This is how your switch populates the CAM key. This is clear. So now you know that what is unicast, what is multicast, what is broadcast, and how the switch populates the CAM key, right? Okay.
Sir, ICMP is L3 protocol, no? L3
Yes.
and RP is L2.
Yes.
Both are working in L2 as well, huh?
So switch is just checking the MAC addresses, right? Switch has nothing to do with these things, right?
Okay.
Will not
Okay.
the layer 3. First, layer 2 will be decapsulated, right?
Okay.
So at the by looking at the layer 2 information only, switch will forward the traffic.
Okay. Okay. And one more doubt, as discussed yesterday, the PC2 is a different network. It will check the default gateway, right?
Definitely it
In
will
case,
correct. So there will be no communication in that case.
no need to check this ICMP and RP, that type of, instead of that one, it will check the default gateway, right? If it is different network.
PC itself will drop the packet.
Okay, fine.
Okay.
Okay, thank you.
Yeah, as of now, IP is not involved. That is something that PC will check, right? At the switch level, it is L2 only. Like I said, switch will never worry about L3, because switch will not even decapsulate this information. Why? Because switch does not have any information about the IP address. According to switch is worried about port number and MAC address. Yeah. So two devices can communicate with the in a LAN, all the packets are forwarded with the L2 only. In a LAN environment, all the packets are forwarded by the switches based on L2 address only. Okay. So kind of you can say this is L2 routing, because switch finds best physical path. Switch will say that, okay, go through this port. Yeah. Okay. Any doubts here? No? Okay. Now here we do have one more condition that is known as what do you think this is? Because when you say flooding, so flooding means what? Through all the ports. And unicast means what? What to one? So what is this condition? What is unknown unicast flooding? Think about it. Switch is an intelligent device, is capable of providing unicast communication. Then what is unicast flooding? Interviewer asked this question a lot. Any idea? No. Okay. Think about it. Let's say this PC here generates a packet, or the switch receives a frame or a packet which has a destination MAC address, let's say M3. Okay. This is a packet which is going for destination MAC address M3. And let's say, for example, source MAC address M1. Right? So when switch will receive this packet, switch will see that, okay, on F0 by 1, I have received a packet from M1. This information is there to me. What is the destination? M3. Do I know where it is? No. But it has a specific source and specific destination. That means type of message is what? Unicast. Message is unicast. But switch does not know where this M3 MAC address is. So switch will try to find out that where this guy is. So how switch will find? By
It
flooding.
will flood the frames to all its ports.
Yes. Switch will flood the particular frame throughout all the ports. Okay, switch will flood the frame out all the ports. Now, through any port switch receives a reply, that port switch will map with the MAC address. But since switch does not know where is the destination MAC address located, that means the information is not there in the CAM table. In that case, for the first time, switch will flood the masses through all the ports. And that situation will be known as what? Unknown unicast flooding, because switch does not know where is the destination. That means it is unknown. Type of message is unicast. And how the switch is trying to know about it? By flooding the message. This is clear? Okay. So if you want to note it down, this thing is available here. Note down this definition here.
Sir, how will the PC1 knows the destination MAC address? Like, if it is not already established the connection, how the PC1 has the source IP, source MAC it already has. How that PC will know the destination MAC?
Okay. Initially, let's say there are two PCs which has already communicated, one-to-one communication, direct cable communication. MAC addresses exchanged. Now I connect them to the switches. Then
Okay.
these are specific conditions. These are not always condition. This doesn't happen every time. Okay. These are few
Okay, sir.
cases, special cases. And sometimes you can generate a packet manually. You can decide what will be the destination MAC. Custom packets also can be designed. Okay. 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 In this diagram, how many collision domains are there? How many broadcast domains? How many collision domain and how many broadcast? In the first
Single broadcast domain and single collision domain.
single collision domain, single broad. What about the second diagram? Three collision domains, one broadcast domain. Now let me go on. Now, eight collision domains, one broadcast. 8 collision domains, one broadcast. Okay, think about it again.
Three broadcast domain.
How many broadcast domains?
Three broadcast domain.
3. Okay. Seven collision domains. 4 broadcast domains. Okay. Okay. Anybody else? How many? Yes, 8 collision domains. Anybody else? Yes. 3. 8. And Hmm? Yes. Yes, you. No idea. Okay. Mhm. Confused.
7 collision, 3 broadcast.
1 collision, 3 broadcast. Switches are there, right? Per port collision. Yes, anybody? Well, broadcast domain. Four collision domain and 7 collision free broadcast. No,
7 collision domain and 4 broadcast domain.
no. 5 collision, 1
Sir, 4 collision and 4 broadcast.
no. 5 broadcast domains.
One broadcast domain and 8 collision domain.
No. One collision. This is the answer. How? Why? Land so. Okay. One broadcast domain. Okay. And how? 5 collision domains. Single collision and purple collision switch PC1, PC4, and between switch. These are single ports, and the connection hubs are one collision domain. Out. 6 collision, 1 broadcast. Okay, see how. This is 1 collision domain, 2 collision domain, 3 collision domain, and 4 collision domain. Because here these are hubs. This entirely is a single collision domain only. Clear? 4 collision domain. Broadcast domain 1. Why? Because default situation switch is also 1, hub also 1 only. So that means if there is any broadcast and any port, what will happen? Generally, how we define broadcast domain? The part of network where broadcast messages can travel, right? Let's say this guy generates a broadcast. So this switch will forward through these ports. Then hub will do what? Hub will also broadcast. This hub will also broadcast. This switch will also broadcast. The broadcast message reached through the entire network. That means only one broadcast domain. Clear? So now clear how 4 plus collision domains and 1 broadcast domain. Okay. Now some people are saying 8. How? Did you count the number of cables? That 8 cables, 8 collision domains.
Sir, can you please show me the markings that you showed in a few? Yeah.
You can note it down if you want.
Thank you.
Here. Then after how unicast travels, how broadcast travels in a switch, that we have discussed. Next part is about VLANs. What, feeling sleepy? Hmm? You can tell me if it is going too much for the day. Okay. So, ready for the next topic? Or enough? Hmm? How many are ready? 1, 2, good. Let's continue. Okay. So VLAN. What is a VLAN? Virtual local area network, right? So if you see here, your VLAN, virtual LANs, provide logical segmentation by creating multiple broadcast domains on the same network switch. This is what a VLAN is. Now, why we are having VLANs? First of all, they provide a higher utilization of switch ports because a port can be associated to the necessary broadcast domain and multiple broadcast domains can reside on the same switch. That means if I have a department where I have only 5 to 10 PCs, I'll use a switch. For second department where again I have 5 to 10 PCs, I don't need to purchase a separate switch. I can create a VLAN and I can use the same switch. I can use the same switch. That will save me some cost, right? And my maintenance will also become easy. Clear? So it provides us higher utilization of the switch ports. That means on a switch, we can go and use all the ports. Okay. Network devices in one VLAN cannot communicate with the devices in a different VLAN via traditional layer 2 or broadcast traffic. So that means two VLANs by default are not going to communicate with each other. Two VLANs are by default not going to communicate with each other. Okay. So VLANs, they are identified in the IEEE 802.1q standard. .1q, the trunking protocol, which states that 32 bits are added to the packet header in the following fields. Okay. So there are some fields added like tagging protocol identifier, which tagging protocol is used. Is it ISL or .1q? So overall 32 bits are added, out of which 16-bit field is set to what? This 8100 for the .1q protocol. Okay. Then priority code point, PCP. This is a 3-bit field that indicates the class. Okay, this is for the QoS basically. Okay, for quality of service. So 3 bits for the quality of service. Drop eligible indicator. This is also related to quality of service only. That is having 1 bit. And your VLAN ID is what? 12 bit. So 12 bit means what? 2 raised to power 12, which is 4096. These many VLANs are there. So in the Ethernet header, these things are added. This is clear? Okay. See here, this is your VLAN packet structure, or you can say Ethernet header, where you have the destination MAC, source MAC, then we have .1q fields. Out of 32 bits, we have 16 bit for the tagging protocol identifier, priority code point, drop eligible indicator, then we have VLAN ID. You can draw this. Okay. Draw this Ethernet header in your notebooks. Then you see up till here, layer 2 information, then after layer 3, and then we have relay. Okay, so in the payload, still we have layer 4 headers where source port, destination port like TCP or UDP header will be there. Then after your data will be there.
Sir, what we call the VLAN packet structure, right? Or Ethernet header.
Yeah, you can call it Ethernet header. Just attach here FCS also at the end. It will become Ethernet header or Ethernet ring, you can say. At the end, if you attach FCS, it will become Ethernet ring.
Okay.
Which one? FCS, frame check sequence. Got it? Okay. Now, the VLAN identifier, it has only how many bits? 12 bits, which provide us 4094 unique VLANs because 0 and 4095 reserved. Okay. Catalyst switches, they use the following logic for VLAN identifiers. So VLAN 0 is reserved for 802.1p traffic, which is basically real-time traffic, real-time communication traffic like voice over IP and all. Okay. So this is reserved for 802.1p traffic and this cannot be modified or deleted. And you cannot even see it in the switches. Then VLAN 1, it is the default VLAN. Again, you cannot modify or delete. VLAN 2 to 1001, this is the normal VLAN range. You can add it, delete it, modify it as per your necessity. Okay, this thing we had discussed in the last session. Then 1002 to 1005, these are reserved and they cannot be deleted. Why? For FDDI and token ring networks. Okay. Then 1006 to 4094. These are what? Extended range of VLANs. These can be added, deleted, or modified as per necessity. Now, how to create the VLANs? So we know VLAN and VLAN number you will give, which is VLAN ID. After that, you can give a name to the VLAN. Okay. Only two comments are there related to VLANs. Easy enough. Do I need to show these things practically? Or you are good with the VLAN creation? Sure. Okay. So I have a switch here. Okay. See here, other than VLAN creation, okay, we do have how you can check the VLAN. So we can use the show VLAN brief command. Okay, specific to a VLAN, so VLAN ID and VLAN ID or name or VLAN name. Or else we can say show VLAN summary. Okay, these are few of the commands that we can use to check and troubleshoot. Okay. Then after, we do have a concept of allowed and block VLAN that also we'll discuss. These are the troubleshooting commands. Access port, run port. So what is an access port? Access port is a member of single VLAN only. Okay. So access ports are the port where you connect your end host. Okay. And they will forward the traffic of a single VLAN only. So you can see access ports are fundamental building blocks of the managed switch. And access port is assigned to only one VLAN. So it carries traffic from the specified VLAN to the device connected to it or from the device to other devices on the same VLAN. That means simply how you can understand that access port is a member of single VLAN and can forward traffic of a single VLAN only, cannot carry traffic of any other VLAN. Okay. While trunk port is by default member of all the VLANs. Trunk port by default is member of all the VLANs and can carry the traffic of all the VLANs by default. Okay. But if you want to filter, we have allowed VLAN and block VLAN concept there. Clear? Now, access port is where you connect your end host, while trunk ports are generally used for switch to switch connectivity or sometimes switch to router or switch to server connectivity. Is that clear? So you can mention it in short about access and trunk. If we talk about access port, first of all, number of single VLAN only. Then can forward the traffic of a single VLAN. Then these are generally used for connecting end host. Okay. While if we talk about trunk ports, so your trunk ports by default member of all the VLANs. Okay. Can by default forward traffic of all VLANs and generally used for switch to switch, switch to router. In some cases, like router on a stick, right? Or switch to server connectivity. Majorly, it will be used for switch to switch. Okay. These two cases, these are only on special cases. Okay. Otherwise, majorly used for switch to switch connectivity. So first of all, let's check show VLAN brief. So these are the VLANs by default we have. So we have VLAN 1 and we have VLAN 1002 to 1005. Okay. And here you see unsupported. These are unsupported. And all the ports of the switch by default member of VLAN 1, that is default VLAN. Now, if I want to create a VLAN, I'll say simply VLAN and VLAN ID. Okay, so I can say, let's say VLAN 10. So VLAN 10 has been created to show VLAN brief.
Well, I think you have to give the name for the VLAN. Only then it will show.
Without name also it is created. Just a moment. Okay, I disabled IP routing here, and you can see VLAN 10 has been created. Now, if I want to assign the name to the VLAN, so I'll say name. Okay, and let's say, for example, HR. So again, if you check, VLAN 10 name HR to show.
Sir, while it become L3 switch, L2 features are disabled.
Yeah, L2 features are disabled. Okay, so you can see here, this is L3 switch. So you can see I changed the name and name has been changed. If you want to remove a VLAN, simply you will say no VLAN. Okay, so if you check, do show VLAN brief now. So VLAN 10 is not there. If I try, let's say no VLAN 1 cannot be deleted. If I try no VLAN 1002 cannot be deleted. Here, if I try VLAN 0, you see, doesn't allow. If I try VLAN 4095, same. Why? Because if I say VLAN and question mark, I can give from 1 to 4094. Now, if you want to assign a port, let's say sales. Okay, so do show VLAN brief. Okay, one more time. Okay, so VLAN 10 has been created. Now I'll try to add some ports into this VLAN, right? So I'll say interface Z0 by 0. Okay, and if I want to change it to the access mode, what is the default mode? Access only. Okay, so let me say switch port mode access to make it as an access port. Then I can say switch port access VLAN. Now if I check, do show VLAN brief. So you can see Z0 by 0 has been added. Okay. Now, if I see, let's say, for example, I check the trunk interfaces to show interface trunk. So right now it doesn't give me any output, you can see, because there are no trunk interfaces. So what I'll use interface Z0 by 2. Sorry. Okay, Z0 by 1. And I change the mode to switch port mode trunk. What it says, because encapsulation method. This switch support both ISL and .1Q. So I have to provide one encapsulation method. How? I'll say switch port encapsulation. Sorry, switch port trunk encapsulation. Okay, and I'll give here .13. And now if I change switch port mode trunk, I don't get any error. This is clear. In packet tracer, the command works directly, but in real scenarios, you have to mention the encapsulation also. Okay. So I have made it as a trunk. So now if I will check do show interface trunk, do you see which interface is the trunk interface? What are the VLANs allowed by default? All the VLANs are allowed. Okay. Now let's say I just want to say that okay, only VLAN 1 should be allowed. Okay. So what we can do is switch port trunk allowed VLAN. Okay. Then if I want to add any VLAN, I can add. If I want to allow all the VLANs, I can say all. Specific VLAN, I can mention here. Let's say I'll say 1. Now let's check. Do show interface trunk. Do you see? Through the trunk interface, only one VLAN is allowed. By default, all the VLANs were allowed. Now only VLAN 1 is allowed. And if I say that okay, maybe I want all the VLANs to be allowed except the VLAN 10. So we have an option, right? I can mention that except the VLAN 10, all VLANs are allowed. Okay, so how? I'll say switch port trunk allowed VLAN except 10. Now let's check. So except 10, 1 to 9 is allowed, 11 to 4094 is allowed. Here. Same way we can mention about blocked VLAN also. Okay. So let me say allowed VLAN. First of all, I'm allowing all the VLANs. Okay, so let's check again. All the VLANs are allowed. Now let's say I want to say VLAN 10 is blocked. Okay. So I'll say switch port trunk allowed VLAN. Okay, so we can remove it from here. Okay, you can remove any VLAN that you don't want. Let's say remove. So this VLAN 10 will be blocked. Okay, so to show interface trunk, and you can see same thing there. So that means we can decide that through a trunk port. By default, trunk port carries traffic of all the VLANs. But we can decide that okay, for which VLAN it should carry the traffic and for which VLAN it should not carry the traffic. That is also we can control through the trunk interface. Clear? So access ports, switch port mode access, trunk ports, switch port mode trunk, then show interfaces trunk. Okay. Native VLAN we will discuss tomorrow. Allowed VLAN I have explained. Okay. All the recordings will be available in the Google Drive. Okay. So we can use the add or remove keywords. Then diagnostic comments are there like show MAC address table and all. So these comments we will see tomorrow. Okay. Then tomorrow we will start with the next topic also. Clear? Okay. So let's keep it here for today. That's enough.